So in problem 3, they give us this diagram. I've labeled some extra stuff on it that we're going to use along the way, but really what the diagram is it's parallel lines L and M. So if you look at line M and line L, they definitely appear to be parallel, and then two more parallel lines, S and T. So S and T also appear to be parallel. So they tell us that angle 1 measures 35 degrees, so I went ahead and I tossed that measure in there for angle 1. And then it asks us for the measure of angle 2. So my strategy when I thought about this problem was, can I try to go through a chain of relationships between angles that's going to eventually allow me to determine what angle 2 is going to measure as. So the first thing that I did is I labeled angle A right here, and I realized that angle A and angle 1 are on opposite sides of intersecting lines, and when angles are on opposite sides of intersecting lines, we call those vertical angles, and vertical angles are congruent. So angle A is going to measure 35 degrees just like angle 1 does. The next thing I did is I came down here and labeled angle B. So angle A is in between line L and line M. Angle B is also in between line L and line M. So A and B are both interior angles, and they're on alternating sides of this transversal T that's crossing those parallel lines, and alternate interior angles are congruent. So angle B has the same measure as angle A, which has the same measure as angle 1. What I now noticed was if I consider these parallel lines, T and S, angle C and angle B are going to be congruent because they're both in like the upper right in relationship to the line that is the transversal, which is line M, and the parallel lines that are crossing line M. Right, this is above and to the right of line M. This is above and to the right of line M relative to line T. So these are corresponding angles, B and C are, and corresponding angles also are congruent. So angle C is 35 degrees. Well, angle C plus whatever angle 2 measures as, that has to give you 180 degrees, since it's pretty obvious that those two angles are going to form a straight line on line M. And so if I think about 180 minus 35, I end up with my measure of angle 2 of 145 degrees. I guess if you look at angle 2, it looks like it's an obtuse angle. There's only one option that's an obtuse angle. So I'm kind of surprised that the options kind of went that route. But it's dangerous to just look at one of these SAT problems, eyeball what you think the answer is, and then go with it, just because a lot of the problems aren't necessarily drawn to scale. So this one seems like it was pretty closely drawn to scale, but we end up with D through the sequence of relationships that we've just discussed.